circuit. So other people will be asking, code, sorry, sir, this question, it says logic circuit diagram or logic diagram. So whether it's a logic circuit, logic diagram, what is the same thing, right? So the most important thing to know here is your basic gates. These are the three important gates. This is the OR gate for addition. So the output will be A or B. So guys, please remember, A is a variable. It's a variable. So it means A is the same as name, for example, name, right? So now why am I using an example name? So remember when you declare these variables, for example, in your programming and stuff, if you say name, it means name can be A or name can be X not, or it can be Y not, or it can be A, B, C, D, it can be anything, right? So it's just a placeholder, right? So this can be A plus B plus C or AB plus D. Then you add it with this, you OR it with this, B, this can be B, C, D, X, Y, Z. It can be anything. It can be anything. You must just always remember that, right? So that's for the OR gate. Then we have an AND. And you will have this input. This is input 1. This is input 2. So the rule is just that A, B, right? That's it. And then we have the inverter. Inverter is the NOT gate. So if you have an A here, whatever input, it will invert the input, right? Okay. So now let's start. So here we have X, Y, Z. So we need to identify our inputs, right? So F is the output. Let's identify the input. X, Y, Z, we have 3. Then W, so it means we have 4. Y, Z, X, Y, Z. So we have 4 inputs, right? So we draw 4 lines. Four conducting lines. 2, 3, 4, right? Then, so we need to know W, X, Y, Z. So this one will be W, just in alphabetical order, just to make the work easier for ourselves. W, X, Y, Z. So now we need to conduct this breadboard on input X, Y, and Z, and now this must go through an OR gate. You see, this is this gate. You see, the one that adds or gate, right? So we're gonna use an OR gate. So one input is gonna be X, the other one Y, the other one Z, but you see X and Y, they must be inverted, right? So let's take our X. So we conduct it here with that point. Then we go to Y, conduct it here. And then we go to Z, conduct it here. So before we take them into our OR gate, this must be low, this must be low. So we just invert the X. Then we invert the Y. Then we put everything into a 3-input OR gate, right? Okay, so we're done with this one. So now we come to this one. This one is W, Y, Z naught. So we take W, we take Y, then we take Z naught. Z naught, we know because it's a naught, we just need to invert it. So I'm clear. And then it makes a 3-input OR gate. All right. So now we know we have our W. We have our W. We have our Y. Then we have our Z naught, right? So we have this term already. So now we are here, the last one, X, Y naught, and Z. So we conduct, on the X, we conduct on the Y, and then we conduct on the Z. So Y is low, so we will put our inverter here just to make the Y be low. Then we just simply have a 3-input OR gate. All right, then it will give us this. So everything 1, 2, 3 is they go into an AND gate. This AND gate has got three inputs, right? So it has this. Remember I said this is just a variable, guys. So let me do this. This, for example, this is a B, and then this is a C, right? So these things are just variables. So now you will get this. So A in this case is X naught, Y naught, Z. Then B in this case is Y or Y, W or Y or Z naught, right? And then C is this term here, right? So hence I'm saying these are just variables. They can be anything. So we're gonna take this. We're going to take this into an AND gate. 3-input AND gate. Then we will have our output F. So this is it, guys. This is your logic gate, logic circuit. Any questions here? Any questions? No questions?